This is the CCEA Maths M4 paper. This one is from May 2022. Let's take a wee look at question 1. A solid cylinder has height of 12 centimeters and a circular cross-sectional area of 34.2 centimeters squared. The density is 0.83. Find the mass of the cylinder. So we could probably fit it in here. So first of all, we need to find our volume. So our volume is going to be 34.2 times by 12. And that gives us 410.4. And we want the mass. So mass is going to be our density times by our volume. 0.83 times 410.4. And we get 340.632. And that's number 1. Number 2, shares are bought with an original value of £1,600. The value increased by 5% each year. Calculate the value after 3 years. Lots of different ways of doing this one. We kind of go a slow method. We go year 1, year 2, year 3. So find 5% added on, find 5% added on, find 5% added on. We're just going to do it here in one lump. So we're going to do 1,600 times 1.05 cubed. And that should give us the answer we're looking for. So 1,600 and that gives us 1,85220. So the 1.05, that represents our 5%. Say it was 12%, it'd be 1.12. Say it was 23, 1.23. And the cube means then this is 3 years. So 1,85220. Question 3, the number of flights delayed at an airport recorded over a 24-hour period. Number of minutes they were delayed were shown in the table below. Calculate an estimate for the mean number of minutes the flights were delayed. So we're doing an estimated mean here, so we need a midpoint then for each of these values. Midpoint of 0 to 20 is 10, 30, 50, 70, 90. And 110, and we do then our midpoint times our frequency, and this here then would be our frequency. So 31 times 10 is 310, 19 times 30 I think is 570, 10 times 50 is 500, 14 times 70 I think is 980. You can just use your calculator if you're not sure. 12 times 90, that's one way though. And then 6 times 110 is 660. We need to total this up, as in the total number of flights. So that comes into 92. We total this up. So just stick this into your calculator. You get 4100. And so my estimated mean then is 4100 divided by 92. And so we get 44.57. So 44.57 minutes. Write down the modal class interval. So if we look back up here, the modal one is the one with the most number of flights. The most number of flights in is 31. So we write then 0 to 20. And we just copy this exactly. So 0 S and T less than or equal to 20. Write down the class interval in which the median lies. So our median here, that's 46. If you divide that, sorry, it's 92. If you divide that by 2, you're going to get 46. So we want to know where the 46th and the 47th flight is in this scenario here. So that'll be 31, and that next 31 plus 19 then is going to take us to 50. So 46th and 47th is going to appear then, this group here. So my answer then is going to be 20 to 40. And that's us. Number 4, the graph below illustrates two monthly tariffs A and B for a mobile phone. Tariff A has a fixed charge per month plus a charge per minute for phone calls. What is the fixed charge per month? So tariff A is this one here, and hopefully you can see that if you do no minutes, you still pay £20, so that's going to be our fixed charge. What is the charge per minute for tariff A? So you could work it out a couple of different ways. You kind of find your gradient here, that would kind of do it. But I'm going to read this information off here. For 200 minutes, it costs £5. You see that? It's gone from 20 up to £25. So it's 200 minutes is £5. £5 in for every 200 minutes. So £5 for 200 minutes. So we want to know per minute. So we would do then 500 divided by 200. So that's now in pence. So then it's going to be 2.5p. Hence, write a formula for the total cost T of tariff A for m minutes. So the total cost T is going to be 2.5 times m. So we need to think about that slightly. It's a bit like a gradient, it's a bit like y equals mx plus c, but for every minute it costs an extra 2.5p plus 20. So let me see, total cost for m minutes, so 2.5, so that's going to be 2,000. So that would be the answer then in pence. If you wanted it in pounds, 0.025 plus 20. Question 5 then, we got to expand this out. So first is x times x, so it's going to be x squared outer plus 5x inner minus 3x, and last then is minus 15. Tidying that up, we would get x squared plus 2x minus 15. Question 6. Two cyclists start from the same location. One cyclist travels due north at a speed of 22 kilometers per hour. I think we're starting from here and heading this direction. The other travels due east at 26 kilometers per hour. How far apart are the cyclists after 2 hours? So after 2 hours, 22 kilometers per hour, this person is going to be 44, and this person in 226s are going to be 52. So they're here and they're here, and we're trying to find this distance here. Hopefully you can see where we're going with this. It's going to be a Pythagoras question, because this then is a right angle triangle. So I'm going to label this in as C, and so C squared is going to equal A squared plus B squared. C squared equals 44 squared plus 52 squared, and C squared, then you put that into your calculator and you get 4640. If you take the square root then of that, the answer would be 68.1. Next question, question 7 then. Simplify 5 minus x plus 10 all over 2. I guess I would just do it all over on the one denominator. So if we times write that, so it's over 2, so that then would be 10 over 2, take away x plus 10 over 2. We can put those together then, so we have 10 minus x. You need to be careful here because we're taking away the 10 as well, minus 10 all over 2. There's a wee point, a lot of people make mistakes. Just be careful that you realize that's a minus. Then the 10 take away 10 gives us minus x over 2. So my answer then is minus x over 2. Question 8. A factory produces 3 types of light bulbs, clear, pearl and yellow. In a week, 4, 5, 3, 6, 0 clear are produced. pearl and colour make up 36% of the total produced each week. There are 4 times as many pearl produced as colour. How many pearl are produced? So, let me see. First of all, the clear ones. There are 4, 5, 3, 6, 0, and that equals 64%. So if we want 1%, we would do 4, 5, 3, 6, 0 and divide it by 64, and that's going to give me 708.75. That means then the pearl and colour make up 36, we know that, so pearl and colour. So the pearl and colour together then must be times that by 36, 25515, that's 36%, which is 25515. Now it says there are 4 times as many pearl as there are colour, so 4 times as many pearl as colour, so they're kind of split in the ratio 4 to 1, so there's 5 parts there, so we need to divide this then by 5. That gives me then 5103. So that would mean there'd be 5103 colour, and then there'd be 4 times that, which is 20412. And that's the answer then. They want to know how many pearl are produced, so it's 20412. Question 9. 180 Year 11 pupils in Glasgow High School were asked to record how much time they spent on their phones one Saturday. The results are shown in the table below. And there we have time in minutes less than cumulative frequency. Complete the cumulative frequency column in the table. So we just add this in as we go along. 6 plus 10 is 16. 16 plus 25 is 41. 41 plus 37 is 78. 78 plus 32 is 110. 110 plus 29 is 139. 139 plus 27 gives us 166, and 166 plus 14 gives us then 180. Over to the next page. We'll probably use this column in just a wee second. Plot the cumulative frequency curve on the given axis. So for that, we need to effectively plot this against this, so the time and it's less than, so we're just writing out these numbers here effectively over here, and that's what we plot. So it's 30, 60, 90, 120, 150, 180, 210 and 240. The other thing we're going to plot is at 0 and 0. So let's take a wee look then and see how we get on. I wonder if I could move the camera out here a wee bit so you can see just a little bit more of what we're looking at. So we're plotting 0, 0, and then my first point, let's take a wee look at it. 30 is 6. Let's just get our scales sorted here. 30 is going to be halfway along here, so that's going to be 30, and then that looks like it goes up in 2, so 2, 4, 6. So I'm plotting that there. My next one is 60 and 16. Then I have 90 and 41. Then 120 and 78. 150 and 110. 180 and 139. Still just about in here. 210 and 166. We're just off the screen here, so we're up to there, and then 240 is 180, and so we have that. Next thing we want to do is then try to join this with our best curve possible, so you don't use a ruler at any stage here, you just join this as neatly as you can, and you try and be as accurate as you can, I suppose. So I think this isn't a bad effort. And so my curve then looks something like that. We'll probably be asked more questions about that. Let's see what they're asking us next. Use your graph to find the median and the interquartile range. Okay, so we will get a ruler here. This goes up then to 180. So my ruler, I want to go across then at 90 and read off the information. Nice thick line going along here, so the examiner can see it. Read across and then down there. And again, remember our scale here, this looks like it goes up in fours because 120, 124, 128, so that then I think is going to be roughly 132. Sorry, let me get this page here. Median, so I'm going to do 132. The lower quartile and the upper quartile then I need for the interquartile range, so we need to go across at 45. So it's going to be here. And then down. I think that's just past. I haven't drawn it very well, but if you kind of look really closely in on that, that's just past the 92, so I'm going to give that a 93 there. So my lower quartile is 93, my upper quartile, let's see, so that's going to be 135. And then read down from there. And that seems to me then just about 177 possibly, I think. 177. Again, yours might be slightly different, but it's all to do then with the accuracy of this. So I have 177 and 93. So I'm going to do 177 minus 93. And that equals 84. Okay, the staff at the same school were also asked to record the time they spend on their phones in the same salary. The results are recorded in the box plot diagram. Compare your results for the pupils and the staff. So we have our median, we have our interquartile range. So let's see what they are then for the staff. So for the staff, the median is this wee middle number here. And that looks to be then kind of 84. So already I can see then the median here is 132, median here is 84, so massive difference. Their lowest mark is 20. Their highest mark is 160, so this is minutes on the phone, is it? Yeah. Their lower quartile, what's that going to be? 56. And their upper quartile is 132. So their interquartile range, and it's going to be 132, take away 56. Which gives us then 76. So the interquartile range is smaller and the range is a lot smaller, so lots of different things then we get right there. So let's get a couple of them. So on average spend more time on their phones. So because the median here is 84 and the median for the pupils then is 132. So pupils spend more time. That might be one. The other one might be that the pupils' data is a lot more spread out. Because the range is bigger on the interquartile range. And I suppose the other one, I mean this only goes up to 200 and the other one goes up to 240. So the maximum time is much higher for pupils. I think that would be kind of three reasonable comparisons for us. Let's see, I'm going to bring this back in again. And that's us. On then to question 10. So it says to solve the following equation. A couple of different ways of doing this. You can multiply through your bracket by 4. Sorry, multiply each of your brackets out and then try and solve from there. But it's always nice if you can to get rid of those fractions. So I'm going to multiply through the whole equation by 4. And that'll just make our life easier right from the start. Now you need to be careful of this. If I multiply through this by 4, I just get y plus 3 minus 8. If I multiply through this by 4, this is half of this. So if I multiply it by 4, I get 2 upon 3 minus 2y. Y plus 3 minus 8, that gives me y minus 5. And then that gives me 6 minus 4y. I would add the 4y to both sides, giving me a 5y, and add the 5 to both sides, giving me an 11. So I have y is 11 over 5, or 2 and a fifth. So my answer to this then is 2 and a fifth. U has coordinates minus 1, 1 as shown. V has coordinates 2, 5 as shown. Find the equation of the straight line joining U and V. So first of all, let's join it. At least we can kind of see what we're working with here. So our straight line is going to be of the form y equals mx plus c. We need the gradient here, so we need the steepness of the line, and then we need the y-intercept. The y-intercept is very straightforward. It's crossing there at 1, so our value of c then must equal 1. The gradient, we work out a number of different ways. I'm just going to go the slow method here, although there are other ways of doing it. We have our 2 coordinates here, so if I use the formula, my formula for gradient is y2 minus y1 all over x2 minus x1. And I call this gradient equation, coordinate 2 and this coordinate 1. So y2 minus y1 is 5 minus minus 1. 2 minus minus 1. That gives me then 5 minus minus 1 is of course 6 over 3. That's 2. Now to be honest, the way I would work out the gradient is see every time you move across 1, you move up 2. Across 1 up 2, so I know the gradients are 2 now. I'm just showing you here they can be done this way. So I know my m is 2 and my c is 1, so my equation then is y equals 2x plus 1. Find the equation of a line perpendicular to uv that passes through the point 0, minus 1. If it's perpendicular, then the gradient is going to be the negative reciprocal. So my line is then going to be minus a half. So the reciprocal of 2 is 1 over 2, and the negative reciprocal then, so it's minus a half, so it's minus a half x, and then my y-intercept, it crosses in at 0, minus 1, so that is my y-intercept. So in that case then, it's going to be minus 1. Question 12. Find the expression in n for the difference between the areas of the 2 squares. So we need to do 4n plus 3 upon 4n plus 3, or 3n plus 4, 3n plus 4. So it's going to be take away 3n plus 4. I'm actually going to keep things in brackets here because I think it'll make life a bit more straightforward. 4n times 4n is 16n squared. And we'll do outer and inner together here. So outer plus 12n, inner plus 12n. So that's going to be plus 24n plus 9. So that's that one. And then take away 3n times 3n gives me 9n squared. Outer and inner plus 12n plus 12n. So that's another 24n plus 16. You don't need the bracket there or there, but it's just much easier. If you put a minus here, you can end up getting confused about what you're doing. So in this case then we're just going to take these away. So 16n squared, take away 9n squared, gives us, of course, wait, it needs fully factorized form. Let's keep writing what it is here. So let's go 7n squared. The 24n, take away the 24n, so they disappear. And then we have 9 minus 16. So that's minus 7. They've asked us for fully factorized form, so we take out the 7n squared minus 1, and then that's the difference of 2 squares. So now we're good to go. So 7n plus 1n minus 1, and that's us then in our fully factorized form. On then to our next question, question 13. Diagram shows 2 vertical masts A and B. A is 210 meters high and B is 1.5 times the height of A. 210 times 1.5 so that's going to be 315. The angle of depression from the top of B to the top of A is 25 degrees. Calculate the horizontal distance between the two maps. So let's draw our wee line here, here, and here. That is our right angle. The angle of depression is 25 degrees, so that means that is a 25, and the distance we know then, of course, is going to be that one, which is 315, take away 210. So that then is going to be 105. So hopefully you see where I've come up with a wee right angle triangle here, and we want the horizontal distance here, so we want this, that's our adjacent, so I'm going to be calling that. So that is the opposite, that's the adjacent, that's the hypotenuse, so we want O and A, so we're going to be using tan. From a tan x is O over A, tan 25 is 105 over A. A bit of rearranging then, we have A is 105 over tan 25. Some people do that in two steps, multiply through by A and then divide by the tan 25. Either of those are good. I think I'm in degrees here, so make sure your calculator is always in degrees. That's a wee D in there. I know soon enough if I'm not. So I'm 105 divided by tan 25. And I get an answer then of 225.2. So that goes into there. And that's us. Question 14, solve x minus 2 all squared equals 10, giving your answer correct the two decimal places. You can do this a couple of different ways. You can do it by completing the square. I'll maybe do it twice just so you can see where we're going here, but you can take the square root there of both sides and you get x minus 2 equals plus or minus root 10. Gives us x2 plus or minus root 10. So we have x is 2 plus root 10, and that gives us an answer of 5.16, or it gives us an answer of then 2 minus root 10, which gives an answer, again, you just type this into your calculator and you'll get minus 1.16. So giving your answer correct at two decimal places, that's what I've done. So 5.16 and minus 1.16. The other way, which you might be more comfortable, if you're not comfortable with complete the square, don't be worrying about that too much, just multiply that out using FOIL. So your other option here would be x minus 2 equals 10. I'll not go all the way through this, but you'll see what we're doing. X squared outer inner minus 4x plus 4 is 10, and that gives me x squared minus 4x minus 6 equals 0, and then that one doesn't factorize, so we would use the formula. So we do A, B and C, where A is 1, B is minus 4 and C is minus 6. You work your way through minus B plus or minus the square root, etc., and you would get exactly the same two answers coming out. Either of those two methods are totally fine for your 4 marks. Question 15, P, Q and R are points on the circumference of a circle, centre O, that's okay. The line ST is a tangent, PRS is 65, PRQ is 53. Calculate the size of angle POQ, giving a reason for your answer. So angle POQ, so because these are subtended from both P and Q, the angle to the centre is always twice the angle at the circumference, so it's going to be 55 times 2, so angle POQ then is 106, because angle at centre is twice angle at circumference. Calculate the size of angle OQR, giving reasons for each step of your answer. So let's go back. So it is OQR R that we need. So we need that angle there. We could do it a couple of different ways. We know that's 106. We've just written that in. If that's 106, then these two must add up to 180 minus 106. So 180 minus 106 is equal to 74 divided by 2. We should know that, so we said it was in our 37. So that's 37 and that's 37. Also then by the alternate segment theorem, this is a tough one. There's your triangle there, and that 65 has to be the same as the 65 there. So that whole angle there is 65. So 65 then take away 37 is going to be that. So we need to write that out and kind of show our methods for it then as we're going our way through. So our first step, let's go for the alternate segment theorem. So we're saying that PQR, so PQR equals 65 degrees by the alternate segment theorem. Angle PQO is 37 by, let me see, isosceles triangle I suppose is the best way of saying that. Again, you can see your answers under there. And so the one that they want, therefore OQR is equal to PQR take away PQO, which is 65 take away 37. And the answer to that one then is 28 degrees. And that's us for that. Okay, on to question 16. The table gives information about the number of hours worked by employees of factory in 1 week. No employee worked for more than 50 hours. Complete the histogram for this information. So we're going to need to work out our frequency density. I always think it would be kinder of them if they give you a couple of blank spaces in this table here to put in your frequency density. So we're just going to put it in right here. And that's my frequency density. For frequency density then you work out by doing 6 divided by the size of this group. So 6 divided by 5, that gives me then 1.2. 32 divided by 10, hopefully you can see that that's going to be 10, is going to be then 3.2. 54 divided by 15 is 3.6. 75 divided by 15, that gives us 5, and then 16 divided by 5, that gives me then 3.2. So if this here is 1.2, obviously that's going to be 1, 2, 3, 4, 5 and 6, my frequency density going up the side, and then from 5 to 15 I want to go up as high then as 3.2, so my 3.2 mark is going to be there. Right, my next one is 3.6 and it goes from 15 into 30. My next one from 30 to 45 should be a height then of 5. That, and then finally 3.2 from 45 to 50. And that's that one done. To investigate the link between job satisfaction and the number of hours worked, explain why a stratified sample is the best method to use here. So obviously you don't want to ask a whole load of people who all kind of work really kind of high hours or low hours. You're better kind of picking so it's selective then of the sample. So our phrase for this is just representative of the data. Okay, a stratified sample of 30 employees is taken from this data. Calculate an estimate for how many employees in a stratified sample worked more than 36 hours. So we need to work out how many work more than 36 hours anyway. We need to know how many employees we're kind of dealing with. So I've already added that up. So 6 plus 32 plus 54 plus 75 plus 16 give us 183. And we need to know how many worked more than 36 hours. So all those people worked more than 36 hours, and some of these people. So we just do our best guess here. So 36 is kind of to 6. This is a group of 15. So 30 to 36, and then from 36 to 45. So that's 9/15 we want of the 75. So we would write 9/15 of 75. And that gives us, that's obviously the same as 3/5. 75 times 0.6, which is of course 45. So we have 45 of those people and then 16 of those. So my 45 plus 16, it gives us 61. And it's 61 then out of 183 people. So that's the fraction. And then we have 30, a sample of 30. 61 divided by 183 is a third, and multiplying that by 30, shockingly of course then, is 10. So at least the answer works out nicely for us, and the answer is going to be 10. Question 17 is factorise 25 minus 0.01 t squared. So that's a difference of 2 squares one. So it's going to be 5 and 5, and then plus and minus, and then it's going to be 0.1 t. And again, if you check that, that will work out if you sit and multiply it out. So 5 plus 0.1 t, and then 5 minus 0.1 t. AB minus CD, so we're going to factorise this. There's no common factors in the first two, and I want them, so I'm going to rewrite a bit of this. So I'm going to go AB minus CA minus CD minus DB. Factorising the first two terms, we have A upon then B minus A. And you know what? Because I'm going to look for a B minus, B minus C. And because I want a B minus C here, that should be a plus anyway. I'm going to write these two the other way around, it just makes life a bit easier. So plus DB minus CD. So we're then going to go plus D upon B minus C. So those factors are then the same. So one of my brackets is A plus D, one of my brackets is B minus C. A plus D, and then B minus C. Sorry, I just had the camera there. Question 18. An employee of a company earns £260 per week for a basic 40-hour week. She is offered a 10% rise in her hourly rate. She is also offered a percentage reduction in her working hours. The combined impact of these changes is a 4.5% increase in her total weekly pay. Calculate the percentage reduction in her working hours. Okay, a few different ways of going about working this out. I'm going to work out how much they get per hour. So if we do 260 divided by 40, then that works out to be £6.50 an hour. If she's offered a 10% rise in her hourly rate, so 10% of that then is going to be 65p. So £6.50 plus 65p, then it's going to be multiplied, I guess, by 1.1, £7.15 is then the new pay. She's also offered a percentage reduction in her working hours. The combined impact means she's 4.5% increase in her total weekly pay. So if we add 4.5% onto this, 260, 1% is obviously 260, 4.5%. This is 1170. So her new pay is going to be £271.70. So what's happening? She's now getting $7.15 an hour. She's now getting 271.70. Let's see how many hours she works. So if we do 271.70 divided by 7.15, we get 38. So calculate the percentage reduction in her working hours. She was working 40 hours a week. She's now working 38 hours a week. So it's 2/40, and 2/40 then is the same as 5%. So it's a reduction then of 5%. Loads of different ways of working that one out, and I think it's quite a confusing question. That's one method for you there. A lampshade is made by removing a small cone from a larger cone as shown in the diagram. The volume of the lampshade is 16625 centimeters cubed. Find the value of R. So we're going to find the volume of the big cone and the volume of the wee cone using the formulas. Then we subtract them, and that's going to give us 16625. So our volume of a cone is 1/3 times pi times r squared times 56. So that's the big one. So it's 1/3 pi r squared h. If you look at the formula on the front of your in your formula sheet, that's what we have. So 1/3 pi r squared h. The r in this case is 2r, and we have 56. Take away 1/3. So this is then for the wee one, times pi times r squared, and times 28 taken away from the 56 gives us then 28. So if we do our sums there, there's kind of a lot to work out, but you can kind of sit and work your way through it. You will get, let me see, I think it's 205.25 r squared. So you would need to sit and work out how many r squared you have here, work out how many r squared you have here, and subtract them, and you get 205.25 r squared. We know the volume is 16625, so that equals 205.25 r squared. If we divide those two, we pretty much get 81, so it works out quite nicely for us. R squared is 81, and we get R, and it's going to be 9. So my answer to that one then is 9 centimeters. On to our next question. We are nearly there. Okay. If sine P equals sine R, show that 12x squared minus 17x minus 5 equals 0. So sine is opposite over hypotenuse. So we would have this over this must equal this over this. So we'd multiply that out, I guess, and try and rearrange it. So O over H is going to be 6x plus 5 all over 12x plus 31. And that equals x over 4x minus 1. This is one of the scenarios where you can do a cross multiplication here, so I'm going to cross multiply. So I have then 6x plus 5 upon 4x minus 1 equals x upon 12x plus 31. multiplying out my brackets, 24 x squared plus 20 minus 6. 6x plus 5, 4x minus 1, plus 20x minus 6x, so it's plus 14x minus 5 is 12x squared plus 31x. Taking things in to one side, take away the 12x squared gives me a 12x squared. 31 taken away from 14 gives me minus 17x. And then minus 5 equals 0. And that's what that asks for. That's the same as that. Hence calculate the size of angle P. So we need to solve this then for x. So I'm going to do 12 times minus 5, so they need to multiply to give me minus 60, and they did add then to give 17. So it's some sort of form then, I think, of 20 and minus 3, or sorry, minus 20 and 3. So splitting my middle term, 12x squared minus 20x plus 3x minus 5 equals 0. Factorizing this, there's a 4 will come out, 4x, 3x minus 5 plus 1, 3x minus 5 equals 0. You maybe have different ways of solving this, but 4x plus 1, 3x minus 5 equals 0. That means 4x plus 1 is 0x, then is minus a quarter. And here we have 3x equals 5, so x then is 5 over 3. So x can't be negative. It doesn't make any sense to have a negative there. Like, you can't really, the answer to that can be minus a quarter. So x then in this case is going to be 5 over 3. So we sub in our 5 over 3 into sine, and we'll see then what we have. So we know, let's see, if we substitute it in into this one, we know that sine P is equal to 6x plus 5 all over 12x plus 31. So that means sine P is 6 upon 5 over 3 plus 5 all over 12 upon 5 over 3 plus 31. That means sine P, let's see if we can work this out. So divide that by 3, you get 2 times by 5, 10. So I think with 15 on the top. Divide by 3, 4 times 20. 20 plus 31 then is 51. So sine P then is 51. And it says find the size of angle P. So it's going to be P then is sine to the minus 1, 15 over 51. And we get 17.1 degrees. Final question. Given that 2 over x plus a minus 5 over x minus a equals 1 has a solution x equals 3, find the possible values of a. So if we know x equals 3, we're just going to substitute that in. So we're going to have 2 over 3 plus a minus 5 over 3 minus a equals 1. Common denominator then. 2 upon 3 minus a minus 5 upon 3 plus a all over 3 plus a 3 minus a equals 1. Top line then becomes 6 minus 2a minus 15 minus 5a, and that equals in, we're going to multiply this up here. So we have 9 minus a squared. I'm going to take everything then over to the one side and try and tidy it up. So the a squared is going to come over here. Minus 2a minus 5a is minus 7a. And then a few numbers are sorted. 6 take away 15 is minus 9. And then take away 9 from that, so it's minus 18 is equal to 0. We want 2 numbers that multiply to give minus 18 and add to give minus 7, so it has to be a minus 9 and a plus 2. That means a equals 9 or a is minus 2.